Welcome back to the subject Object-Oriented Analysis and Design. Today's topics are activity diagram, benefits of activity diagram notations, activity diagram example. So the uniform modeling language includes several subsets of diagrams, including structural diagram, interaction diagram, and behavioral diagram. So under the UML diagram, there are various types of diagrams are there. Some diagrams will comes under the structural, some comes under the interactional, and some comes under the behavior. So this activity diagram along with the use case and state chart machine diagram are considered behavior diagrams because they describes what much happens in the system being modeled. So these three diagrams, that is activity diagram, use case diagram, and state chart diagram, all these diagrams comes under the behavior diagrams. So stakeholders have many issues to manage, so it's important to communicate with clearly and briefly. So as we discussed in the evolutionary and iterative. So people used to interact, like the stakeholder used to interact with the developer or with the analyst. So whenever they are interacting, they used to collect all the functional and whatever the requirements in terms of use case diagram. So as we discussed in the last class, all the requirements and the functional requirements will be collected by an analyst by using the use case diagrams. So in the same way, whenever they are communicating, the way of communication, whatever they had discussed, everything will be represented by using this activity diagram. So they will be making the things or taking the inputs in terms of this activity diagram. So this activity diagram helps the people on the business and development sides of an organization come together to understand the same process and behavior. So benefits of activity diagram is nothing but this activity diagram presents a number of benefits to the user, like demonstrating, if we take an example of an demonstrating a logic of an algorithm. So whenever the analyst is drawing any algorithm, like they are going to develop an algorithms before going to start developing the code. So if you take that particular example, describe the steps performed in an UML use cases, illustrate the business process or workflow between the users and the system, simplify the improve and process of by clarifying complicated use cases, model software architecture elements such as methods, functions, and operations, everything can be defined in terms of an activity diagram. So if you go for developing anything, before going to develop anything, the analyst used to collect all the communication work, whatever they are communicating with the stakeholder, everything can be defined in terms of an activity diagram. Right here, we had just gone through with one of the logical algorithm. Whenever the analyst is doing the analysis before going to develop any code, so that will be represented in the particular activity diagram. So these are the notations to develop the activity diagram. The first one is an activity. It uses to represent a set of actions. So whenever you're going to define any action, like what action, but the developer is going to take. What is the first step of going to develop the project or any problem statement? So this particular notation will represent the set of actions. The second one represents the performance, a task to be performed. So this action will represent the task to be performed. The third one is the control flow, shows the sequence of the execution. Whereas the fourth one is an object flow, shows the flow of an object from one activity to the another activity. So don't get confused between the control flow and the object flow. So control flow is then flow of direction, like the sequence of an execution, whereas an object flow is nothing but which is a flow of an object from one activity to the another activity. So next one is an initial node. This is similar like a flow chart, which will be a shaded circle, which is the beginning of the whatever the activity diagram represented by using the initial node. Whereas the final node is the end of the activity diagram. So to represent where the activity diagram is going to start and where it is going to be end, by using this initial node and final node, that represents that the starting and ending of an activity diagram. So coming to the next one, object node. So which is an rectangle box, represents an object that is connected to a set of objects. Whereas the next one is a decision node. So if you see, this is a decision node which is having the flow of direction towards outside. So whenever it is towards an outside, we will defines as a decision node. Whereas coming towards inside, so for any decision node, if the flow of direction is toward inside, then we'll call it as a merge node. So here also don't get confused that if the flow of direction is from decision node to towards an outside, we'll call it as a decision node. And if the flow of direction is towards inside, incoming, then we'll call it as a merge node. Coming to the next node, which is called as a fork node. So here also in the fork node, which consisting of one input and two outputs. Whereas the next one is a join node, which is having two inputs and one output node. So this is an opposite to the previous one. Coming to the next one, swimline and partition. So if you want to represent the way of grouping the activities, so if you want to group more than one activities by using the swimline and partition, we can make the partitions and differentiate the more than one activity. So all these are the notations to draw the activity diagram. So let us see that what are the internal each and every element here. This is a precondition and this is the starting of an activity. This is nothing but an actor input. So from here, the actor is going to be giving an input here. The next one is a system step, defining the things here, activity, action can be done. Then we'll have a decision, alternative or extension flow can be there from decision. Next one is the basic flow. We can see the flow of direction based on the condition, true or false or yes or no. It can be taken to the next stage, which is returning the alternative flow. And from there, we can see here more than one, that is one input and more than one outputs. That is a two outputs you can taking, which is called as an fork node. And here it is performing the parallel activities. And the next one is the post condition. That is an end of the activity diagram, which is represented with a shaded circle and one more circle that is an outer circle to this. So this is nothing but flow of direction, how it works, which is similar like an flow chart. So just to say that activity diagram, which is nothing but the behavior of this activity diagram is similar like an flow chart. So that is the reason we took an example of whenever to define any algorithm, this activity diagram is helpful to define the flow of direction. Coming to the next one, if you take one example of modeling a word processor. So think that the developer used to work and some documentation and that can be represented with this activity diagram. So if you see here, the first step is example below describes a workflow for an word process to create a document through the following steps. Open the word processing package. So initially word can be opened, create a file. So save the file. Then save the file under a unique name within its directory. Type the document. If graphs are necessary, open the graphic package, create the graphs, and paste the graphs into the document. If the spreadsheet is necessary, open the spreadsheet package, create a spreadsheet, and paste the spreadsheet into a document. Now, once the work is completed, save the file. Print a hard copy of the document, exit the word process package. So think that this is one of the small exercise which is done by a particular developer or an analyst. If we take this example and if you draw an activity diagram, let's see how we can draw the diagram. So here is an initial node. From the initial node, open the word processing package, then create file, save the file, type the document. If the while you're typing the document needs any graphical elements to input, then go back to the open and use the graphical packages, include the graphical elements and come back again. If you want to add any spreadsheet to that, open the spreadsheet. Using the spreadsheet, whatever the operations you want to perform, complete that and then save the file, print the hard copy, exit from the office suite, whatever the site it is. So this is nothing but just like a flow chart, which is going to be define the activity diagram. Example for how to print and document. Coming to the one more example, an application wants to enroll, applicant want to enroll in an university. So whenever a student want to apply or to enroll to any university, what are the procedures or the activities that take in place? So if you see here, the applicant handles a filled out copy of enrollment form. The registrar inspects of the form. The registrar determines that the form have been filled out properly or not. The registrar inform student to attend in university overview presentation. The registrar helps the student to enroll in seminars. The registrar asks the student to pay for an initial tuition. So these are the activities that are performed once the student wants to apply for any university, to enroll any university. So if you just draw an activity diagram for this particular case study, so let's see how to draw this. So the initial node, so from the initial node, fill out the enrollment form. Once the form is filled, enroll in the university. And here, if they are not going to be enrolled, like if there is any corrections are needed, any help is needed, obtain help to fill out the form. So once they clarified the doubts, once again they come back to the enrollment form, enroll in the university. So if you come here, here also we can see there is a streamline. This is a streamline, we can see. It is a fork which is having one input and two outputs. So parallelly it is performing the operation. One is the enrolling for the seminar. The second one is attend the university overview presentations. So if you want to present two activities at a time, then we can take one input and two outputs. At the same time, once the enrollment for the seminar is completed, make initial tuition fee. So we are including here itself. Once the person is enrolled for the seminar, paying the fee for that, and this action is completed, it is going to be end. So this is very simple example that we can easily understand, including the starting node and activities and the condition. And then we can see the fork and join. This is a fork activity, one input, two outputs. And the join condition is two inputs and one output. And it is going to be ended. Right? Very simple to understand this. Coming to the one more example, swim lane is a way, like what is an exactly a swim lane? It is nothing but is a way to group activities performed by the same actor or an activity diagram or to group activities in a single thread. So in this example, we can see the same example which we discussed previously. So here is an example of a swimline activity diagram for modeling staff expenses submission. So along with that enrollment, we can also see how a staff is going to be submit the submission of the expenses. So here it is going to be parallelly partitioned into three. The first one is a payroll services. The second one is a accountant and the third one is a consultant. So initially it is starting from the consultant, input the node, fill out the expenses form. So here the employee is filling the form under the consultant. Once the consultant fill that, it is going to move towards the accountant. Here we can see the expenses form, which is collected from the accountant. And once it is collected from that, we are going to be validate the expenses. So here you can see that expenses form is error. So while they are filling the form, if any details or the dates are missing, again, it is considered as an error. The condition is going back to fill out the expenses form. So if it is invalid, and then directly it is going to be enter the expenses in payroll. So once this payroll is completed, payroll services. So the condition is coming back to the payroll services. And here the payroll file is going to be filed and then it is going to be paid to the employee. So by this activity is going to be end. So this activity diagram, if we want to parallelly show more than one activities at a time, then we can apply the swimline technique. Where in this swimline technique, parallelly we can define more than one actions at a time and we can connect to each and every activity. So initially it is starting from the consultant and from there, once the formalities are completed of enrollment, then condition is moving towards the accountant, checking for the expenses valid or not valid. Once the validation is completed, then the control is moving to the next position, which is the payroll services. And under the payroll services, if the enrollment is success and at the same time accountant is confirmed the validation, it is going to pay the file and the payroll file is going to be filed and employee is going to get the fee. There is a pay, right? So this is a simple example in understanding the activity diagram. That's all. Have a good day. Thank you.